First important law, Faraday's law is a time varying magnetic field. A time varying magnetic field. Magnetic field changes with respect to time. A time varying magnetic field produces an induced voltage. Produces an induced voltage in volts in any closed circuit. In any closed circuit is equal to the time rate of change of the magnetic flux linkage by the circuit, which causes current flow. Important point is which causes current flow. Static magnetic fields produces no current flow. Only time varying magnetic fields produces an induced voltage in a closed circuit. Complete circuit is equal to time rate of change of the magnetic flux linkage by the circuit, which causes current flow. Mathematically, it can be expressed as mathematically as V EMF is equal to minus d lambda by dt or minus n into d psi by dt, where psi is called as a flux, magnetic flux, where n is the number of turns in the circuit. Here negative sign, the negative sign shows that the induced voltage VEMF acts in such a way as to oppose the flux producing it. Where n is the number of turns in the circuit. Suppose transformer is there, primary winding turns and secondary winding. These two are related with some N1 by N2, N2 by N1 based on the step up and step down transformers. The negative sign shows that the induced voltage acts in such a way as to oppose the flux producing it. Okay. Consider an electric circuit. This is the related to magnet. A time varying magnetic field produces an induced voltage in volts in any closed circuit is equal to time rate of change of the magnetic flux linkage by the circuit, which causes current flow. A static magnetic field produces no current flow. Mathematically, it can be expressed as VEMF is equal to minus d lambda by dt, that is equal to minus n d psi by dt, where psi is called as a magnetic flux. The magnetic flux linkage changes with respect to time, where n is the number of turns in the circuit. Next, consider an electric circuit. This one case 2 here, case 1 completed, case 2. Consider an electric circuit, circuit shown in figure. This one is EF. EE. One is positive and negative, neutral. One is E. This one is battery. Battery is a source of EMF. The electromechanical action of the battery results in EMF produced is called as produces a field, not EMF, is EF. Battery is a source of EMF. This one is battery is a source of EMF. Going next one. The electromechanical action of the battery results in an EMF. An EMF produces field EF. The electromechanical action of the battery results in an EMF. Electromotive force produced field EF, electric field EF inside that battery. Second one is two types of fields are there, EF field and EE field. EF field is due to electromechanical action of the battery. EE field is due to accumulation of charges. Next one, due to the accumulation of charge at the battery terminals, an electrostatic field, EE also exists. Inside the battery, we have two fields, EF and E. EF is due to mechanical action of the battery. E is due to accumulation of the charge at the battery terminals. Total electric field E is equal to, inside the source, battery source, E is equal to EF plus E. Total electric field. Okay. EF is 0 outside the battery. There is no electromechanical action at the outside of the battery. Therefore, EF is 0. And the EF and E have opposite direction in the battery. In the battery, EF direction is upward, E direction is downwards. Next point is EF is 0 outside the battery. EF and EE have opposite direction in the battery. Next important point here is the direction of E inside the battery opposite to that outside. The direction of E inside the battery and outside. Battery is opposite to that outside. E is also available inside of that battery, and E is also available at the outside of the battery. These two are opposite. The direction of E inside the battery is opposite to that outside. Integrating above equation about the closed circuit, that is from P to N. Consider length is from P to N. Integrating, consider this equation. Total electric field is equal to EF plus E. Total electric field is equal to EF plus E. Integrating above equation over the closed circuit. Integrate above equation. This is equation 1. Above equation 1 over the closed circuit. Length, consider this length E dot dl. dl is equal to length, here length, EF plus EE dot dl. EF dot dl plus EE dot dl. Because of E, where this value is 0. This value is 0. This one is through battery. E and in the outside E and inside E are opposite direction to each other, therefore cancel. Because of E is conservative, where E dot dl is 0. Because E is conservative. Therefore, this line integral is nothing but the over this length from P to N is nothing but V EMF. Is nothing but V EMF. Therefore, the EMF of the battery is the line integral. The line integral of the EMF reduced field. That is VEMF is equal to negative to positive, neutral to positive, EF of dl. And EF and E are opposite direction inside the battery. Therefore, neutral to positive minus integral neutral to positive EE dot dl. In the closed circuit, this EMF is equal to this EMF. This is the EMF. V EMF is equal to I into R. I into R. That is equal to I into R. To case 1 and case 2. In case 1, this is the case 1. Case 1, VEMF, induced EMF is equal to minus N into d psi by dt. In case 2, induced EMF is equal to integral over line N to P EF dot dl. Consider VEMF is equal to minus N into d psi by dt. For N is equal to number of terms in that coil, N is equal to 1. Therefore, VEMF is equal to minus d psi by dt. EMF is equal to minus d psi by dt. This is the equation 1. Another equation is VEMF is equal to integral over line electric field dot dl. This is the equation number 2. This is the induced the induced EMF in equation 2 indicates a voltage about a closed path. Such that if any part of the path is changed, the EMF will also changes. Next one. The magnetic flux phi passing through a specified area is given by the magnetic. We know that the magnetic flux phi passing through a specified area is given by phi is equal to integral over surface B dot ds. This is the equation number 3, where B is called as my magnetic flux density, magnetic flux density. This is important one. From equation 1, VEMF is equal to minus d psi by dt minus d by dt. Psi is from third equation, psi is equal to this one, integral over surface small area ds bar. This is the fourth equation. Second and fourth equations. Induced EMF, both electric and magnetic fields. VEMF is equal to integral over length electric field E dot dl is equal to minus d by dt integral over surface B dot ds. A surface area of the circuit bounded by the closed path. This is considered surface area, and this is the path, closed path. The surface area of the circuit bounded by the closed path L. This is the equation 1. The variation of, suppose The variation of flux with time may be caused in three ways. First one, the variation of flux, mag flux with time. With time may be caused by maybe caused by may be caused in three ways. By having a stationary loop in a time varying magnetic field. First one is by having a stationary loop in a time varying magnetic field. In a time varying magnetic fields. Transformer EMF, that is called as transformer EMF. In transformer, two coils are there. Two coils are very close to each other. That is a stationary loop. The time varying current produces time varying magnetic field. Due to the time varying magnetic field, that flux linkage takes place. Therefore, induced EMF is produced. A constant induced EMF is produced. That is called as by having a stationary loop in a time varying magnetic field. Consider in this case, consider EMF equation already derived. VEMF is equal to integral length E dot dl is equal to minus surface integral dB by dou B by dou T dot ds. The EMF induced, this is EMF. The EMF induced by time varying current producing the time varying field in a stationary loop is often referred to as a transformer EMF. Very, very important point. The EMF induced current induced EMF induced by the time varying current producing the time varying magnetic field in a stationary loop is often. Stationary loop means two coils are stationary, not in rotating mode. In a stationary loop is often referred to as a transformer EMF. Applying Stokes theorem to this line integral, the line integral is converted into surface integral. Integral length over E dot dl is equal to, apply Stokes theorem to this integral, converted into surface integral, del cross E dot ds. Therefore, del cross E dot ds over a surface is equal to minus of integral over surface dou b by dou t dot ts. ఇక్కడ ఏంటంటే అప్లై స్ట్రోక్ థియరం, ఇది అప్లై స్ట్రోక్స్ థియరం. The line integral is converted into surface integral. Instead of the c dot dl, we use the surface integral. These two surface integrals are cancelled. Therefore, finally, del cross E dot ds is equal to b by dou t dot ds. Del cross E bar is equal to minus dou b bar by dou t. This is the stationary loop. Stationary loop means transformer. Transformer having two coils, primary winding and a secondary winding. These two, that one is a fixed one. The current flow through these coils are changes. The time varying magnetic field is produces. Time varying magnetic flux is produced. That flux is a linkage linked by the secondary coil. Therefore, induced EMF is produced. That is the case one. B is not varying with time. Suppose B is not varying with time. Varying with time means dou b by dou t is equal to 0. Del cross E is equal to 0. Next one, integral E dot dl is equal to 0. This is the case one. Case two, magnetic field is stationary, constant, not varying with time, while the closed circuit is revolved to get the relative motion between them. A fixed magnetic field is produced between two coils, not varying with time, but the closed circuit, that is closed circuit revolved to get relative motion between them. This action is similar to generator action. Hence, the induced EMF is called as a motional or generator EMF. Consider that a charge Q is moved in a magnetic field B at a velocity V. Then the force on a charge is given by F is equal to Q into here magnetic field is a constant one and closed loop the uh, circuit revolved movement is takes place between this stationary magnetic field. Therefore, F is equal to EQ. F is equal to EQ. E is equal to F by Q. F by Q is V bar cross B bar. Therefore, by using this one, integral of EM and DL bar, induced EMF over length. EM is V bar cross B bar dot DL bar. Therefore, VEMF is equal to integral over L EM dot DL bar is equal to integral over L V cross B bar dot DL. This one is case 2. Conductor is moving but fixed magnet. In case 3, the magnetic flux density is also varying with time. Induced EMF is a combination of a transformer EMF and a generator EMF. This is the generator EMF. This one is the generator EMF. First one is a transformer EMF. In case 3, the magnetic flux density is also varying with time. Then the induced EMF is the combination of this induced EMF is the combination of transformer EMF and generator EMF.